Continuing on where we left off in our notes, let's talk about parallel and perpendicular lines. We know that two lines are parallel, we know this from geometry class, if they never intersect. In other words, if they have the same steepness or the same slope. So notice in this first example, the slope of the first line is 2 and the slope of the second line is 2. They are parallel because they have the same slope. On our next part, we're talking about perpendicular. Perpendicular lines form at a 90-degree angle. They intersect to make a 90-degree angle. Their slopes are not going to be the same. In fact, they're going to be as opposite as they can be. They are going to be opposite signs, so this is positive, this is negative, and they're going to be reciprocals, 3/1, 1/3. They're going to be as different as they could possibly be. And when you multiply their slopes together, you're going to get -1 if they are perpendicular. This is important information because sometimes you're going to be given problems like this where they ask you to write an equation of a line in slope-intercept form that goes through this point, and we want it to be perpendicular to this line. So let's start off with what the problem says, slope-intercept form. I know that that form is y equals mx plus b. I know if I use this recipe, the ingredients I need are the slope and the y-intercept, hence the name slope-intercept. Now, looking at this problem, nowhere does it say the slope is such and such, and it does not tell me what the intercept is. That tells me a point, but that's not an intercept. That's just a point in the coordinate plane. So I can't go straight into this. But let's think about the ingredients we have. We have a point, and we know we want it to be perpendicular to this line, and we can tell what the slope of this line is. So we really kind of have a point and a slope. So let's start with that recipe instead. And from there, we will convert it over to slope-intercept form since we didn't quite have the right ingredients. Okay, the point is 5, -6. This is the x, this is the y. X goes by x, y goes by y. -6. It cancels out the negative in the formula. Now we need the slope, and they tell us perpendicular to this line. The slope of this line is -3/2. If that slope is -3/2, then the perpendicular line, the slope of that line, is going to be the opposite, so positive, and we flip it, 2/3. Since we want it to be perpendicular, that is our slope. Now remember, they want it in slope-intercept form, so we need to distribute. And we need to subtract 6 from both sides. I'm going to write 18/3 so that I don't have to get my calculator out. That's the same thing as -6, if you recall. So y equals 2/3 x minus 28/3. That is my slope-intercept form. That is what I could have written right here. 2/3 x minus 28/3. This next one tells me that I wanted to go through a point. So again, I am given a point parallel to this line, and the slope of that line is 3/4. So I know what the slope is going to be of my line. All right, let's take a look at this. Slope 3/4. The point that we're given is 3,7. Now it's just like a problem we did earlier. We have a point, we have a slope. We'll put it into this formula. Y, x, Slope goes right here before the parentheses. We'll distribute. And we'll add 7 to both sides. But again, so I don't have to use my calculator, I'm going to call that 728 over 4, because that's the same thing. Y equals 3/4 x. Let's see, if we take away, that would be 19/4. All right, that's our answer. Inequalities are not much different than equations as far as the steps for graphing them, but we have 2 new things that we need to do. When we graph a line, let's make some notes over here. To graph a line, begin with the B, or the y-intercept, and move M, which is the slope. Now, you can also begin with any point that you're given, but when you have an equation, you'll usually just be able to identify the y-intercept. Now, to graph an inequality, you're going to do these same steps, but we also need to decide if the line is dashed or solid. And we also need to shade one side of the graph. We're either going to shade above the line or below the line. Now the line is going to be dashed if it is strictly less than or strictly greater than. It's going to be solid if it's less than or equal to or greater than or equal to. The first thing I want to do is get it in slope-intercept form so that I can see what my slope is in my intercept. I'm going to subtract x from both sides. I'm going to divide by 4. I don't have to change my symbol because I didn't divide by a negative. That gives me 1/2 minus 1/4 x. Now we can begin. We want to begin at 1/2. So I need to make my graph a little bigger. 1/2, and I want to go up 1, down 1 because it's negative, right 4. Down 1, right 4. Or I could go up 1, left 4. That accomplishes the same thing. Now because I like really nice lines, straight lines that is, I'm going to grab my line feature and I'm going to put this line right through the points as nicely as I possibly can. Take your time for this part. All right, so I've completed finding my line. Now I need to go on to step 3. Should it be dashed or solid? Well, looking at the original problem, it's strictly greater than, so it needs to be dashed. So I need to go back and make my line dashed. You can graph it with a dotted line to start with. I find it easier to graph the whole line and then make it a dotted line. Now we need to shade. As long as you have y on the left and your inequality is in slope-intercept form, this tells me to shade above the line. Shade greater than the line. So I would shade above the line. Now, if that seems a little difficult, we can also use a test point. We have to pick a point not on the line. The best point to pick is 0, 0 if we can. And let's put it back into our original problem and check it. Is 0 plus 4 times 0 greater than 2? No. That means we do not shade that point. If it was true, we would have shaded this side that has the red dot. If your line goes through the origin, you can pick any point. 0 is just a very friendly point to pick because it's easy to compute with. All right, let's try another one. Let's go ahead and solve this inequality for y. We're going to subtract 3x and multiply by 2. So I have y is less than 4 minus 6x. I'm going to begin at 4, and I'm going to go down 6, right 1. Down 6, right 1, or up 6, left 1. I know it's a negative slope. I know it has to go downhill from left to right. I also know that it is strictly less than, so I need to grab my small eraser and make it dashed, which means this line is not part of the solution. It's a boundary, but it is not part of the solution. And now I need to shade, and when your line is fairly vertical as ours is, it can be very tough to tell which side to shade. Reading this, it says shade less than the line, shade under the line. So I think we're going to shade here towards the left, but let's go ahead and test a point. Let's pick 0, 0. Let's go back to our original problem. And we're going to put zeros in. 3 times 0 is 0. 1/2 times 0. Is that less than 2? It is. So sure enough, we were right. We are going to shade the side that has our test point, our red dot. Make sure you shade completely. Shade this entire side from the top of the graph all the way to the bottom of the graph as neatly as you possibly can, because as we get into step 8, we're going to need to be really good at doing this process. All right, let's talk about constraints. Constraints are conditions that the solution of a problem must satisfy. You can kind of think of it as a limitation, a restriction. You can do one thing, but you have to pay for it. For example, in our first example here, we have a recreation center. They offer 30-minute and 60-minute art classes. The director has allowed it up to 20 hours per week to be used for the art classes. So when we write an inequality, granted we have the answer written right here in our picture, but let's do it ourselves. How would we come up with that equation? Well, first we need to define the two things that are happening. We have 30-minute classes, and we also have 60-minute classes available. You'll always have two different things that we're talking about, two different variables. Now, we want to write an inequality that says up to 20 hours a week. Well, how do you figure this out? Well, we take the number of 30-minute classes and the number of 60-minute classes, but we want how much time, not the number of them. If they said we can offer only 50 classes a week, we could put less than 50, but that's not what it says. It says hours. So that means we have to put the time, or the value of the time, into our inequality. We have to say 30 minutes and 60 minutes. And that must be less than or equal to 20 hours. But I can't have minutes on the left side of my inequality and hours on the right side. It won't work. So I have two choices. One option, I can change this into minutes by multiplying it by 60, and I get 1200 minutes. So now the left side and the right side are both in terms of minutes. Well, why is that unfortunate? Well, because who wants to graph something with 1200 in it? That's a very large graph. So instead of changing these to minutes, we're going to keep these hours, and instead we'll change our minutes side of the inequality to hours. 30 minutes is a half of an hour. 60 minutes is 1 hour. This looks much easier to graph. In fact, all we have to do is move half x to the right side of the inequality. We would begin at 20, and we go down 1, right 2, down 1, right 2. It is a solid line because it is less than or equal to, and we shade under the line. Now, we only have part of a 4-quadrant graph. We're only looking at the first quadrant. Why is that? Well, we can't offer -5 30-minute classes or -20 60-minute classes. The number of classes will always be positive, so we only need to graph in our first quadrant. We can kind of chop off the other 3 quadrants. Next, it says, can the recreation director schedule 25 minutes of the 30-minute classes and 15 of the 60-minute classes? Well, if we see where these would intersect, the point is right here, which is outside our solution area. So the answer is no. No, the director cannot, because this combination is more than 20 hours. In other words, if we do 25 times a half plus 15, we're going to be more than 20. So it would not work.